Hi folks, we're going to take a look at number 5 from page 550. So let's take a look here. They give us 3 points that lie all in the same plane, and they say determine the distance from point P to the plane containing these 3 points. Okay, so here it's a combination of a couple of things that we've done. So I can determine the equation of a plane given 3 points, and I can either determine the vector equation or the Cartesian equation, but given that my distance formula makes good use of the Cartesian equation, that's what I'll do. Okay, so let's start by determining some direction vectors, which will then cross to determine the normal vector. Okay, so I'll take the vector AB. So that is equal to -3 minus 1 and -4, -1 minus 2, -3, and 2 minus 3, -1. Okay, and then I'll take the vector AC. So 13 minus 1 is 12, 4 minus 2 is 2, and -1 minus 3 is -4. Okay, now I could use these vectors, but again, I need any vectors that, can lie on the plane. Okay, so we know that any scalar multiples of these can also lie on this plane. So instead of using AB, I'll use this vector U and turn this into 4, 3, 1, so I can work with the positive version. And here I'll call the next one vector V, and I'll simplify this by dividing by 2, so I end up with 6, 1, -2. Okay, and these are the 2 vectors I'm going to cross. Okay, so let's go ahead and do that. We've got 4, 3, 1, an extra 4, 6, 1, -2 with an extra 6. Okay, and that gives us our cross product of -6 minus 1 is -7. Here we've got 6 minus 8 is, 6 plus 8, 6 minus -8, so 6 plus 8 is 14. And so here we've got 4 minus 18, which is -14. Okay, so again, I need a normal vector for this plane. Any vector parallel to this vector will also be normal. So the normal vector I'm going to use will be the simplified version here. So I'll divide this by -7 to get 1, -2, 2. Okay, so I'll always try to use the simplified version of the normal vector. Okay, so now I need to find the equation of this plane. So I'll pick, A looks like the easiest one to use. So 1, 2, 3 will be my point, and stick everything into the Cartesian equation. So our A value is 1 times our X value for a point is, also 1. Okay, plus our B value is -2 times 2, plus our C value is 2 times the Z value is 3, plus D is equal to 0. Now notice how I keep the D on the left-hand side to make sure I'm solving for that number there, since I'm going to be using the distance formula. Okay, so let's see what we have. D is equal to, so 1 minus 4 is -3, plus 6 is 3. Bring that to the other side. Gives me -3. So the equation of my plane is, there's my normal vector, so it's x minus 2y plus 2z minus 3 equals 0. And we're trying to find the distance from this plane to the point 1, -1, 1. Okay, and so now I can just apply my distance formula. So the distance is the absolute value of this left-hand expression evaluated at the point I'm finding the distance to. So it's 1 minus 2 times -1 plus 2 times 1 minus 3 all over the magnitude of the normal vector. So the normal vector is 1, -2, 2. So 1 squared plus -2 squared plus 2 squared. So what do we have here? We have 1 plus 2 is 3, plus 2 is 5, minus 3 is 2. Absolute value of 2 is just 2. And in the denominator, what do we have? 1 plus 4 plus 4 is 9. Square root of 9 is 3. And so there you have it. The distance from the point to the plane containing these 3 points is equal to 2/3. Okay, So here, this wasn't so much a difficult problem as it was a long problem, but just a couple of reminders here that when you can work with simplified vectors, please do so. Okay, makes the algebra easier all along the way. Okay, that's it for this one.